Hello friends, my name is Salahuddin. Today I will discuss about the 0-1 knapsack problem. Here I have 4 items A, B, C and D with their weight and value, and I have also a knapsack to keep those items into my knapsack. But the problem is that the total weight of my items is 1 plus 4 plus 2 plus 5 equal 1, 4, 5, 7, 12. So I can't keep all those items into my knapsack, as the total weights of those items is greater than the capacity of the knapsack. So I need to choose items wisely so that I can maximize the value. Here I have a table to solve the problem. Here there is a 80 column, the capacity of the knapsack 7, and here the rows are representing is items. Here I need to take those items in a shortest way. That means first the 1, 2, 4 and 5, A to C, it represents C, and this one represents B. After sorting, I got A, C, B and D. And each field of this table represents the maximum obtainable value. That means in this position, when the capacity of my knapsack is 2 and I have those 2 items, 1 and the weight of 1 and 2, that means A and C, then in this field will represent the maximum obtainable value using those items and when the capacity of my knapsack is 2. Okay, when the capacity of my knapsack is 0, I can put any item into the knapsack. So the maximum obtainable value will be this field's 0. Again, when I don't have when I don't have any items, but I have the knapsack, so I can put any item into the knapsack and the maximum obtainable value will be 0. These are the base cases. Now we will see for A items. Here when we will use the item A for this field, then the obtainable value will be using the item A 5 plus I have already used 1 size, and here the capacity of the knapsack is 1, so the remaining size will be 0, and this 0 will point this 0 as I have used already 1 size, and I have also used these A items, so I don't have any remaining items. This will point in this field. So in this field the maximum obtainable value we know that 0. So for this field, using this item, the obtainable value will be 5. Here again, without using this item, we know maximum obtainable value will be 0 when the capacity of the knapsack is 1. Here the maximum value is 5. So this field, the maximum obtainable value will be for this field is 5. So the process is that to find out the maximum obtainable value of a field is that using the item, we will find out the value using the item and compare with the not using the item. Like for the next field, in this field, I have only the item A and the capacity of my knapsack is 2. So if I use the item for this field, the value will be 5 plus I have used the item A, so my remaining items will be this column, and I have used one size, so my remaining size will be 2 minus 1 equal 1. This will represent here, and the value of this the maximum obtainable value on this field is 0 equal 5 using the item A. And not using the item A, the maximum obtainable value will be 0 when the capacity of the knapsack is 2. Here I will find out the maximum value. The maximum value is 5. So the maximum obtainable value of this field will be 5. Same when the capacity of my knapsack is 3, 4, 5, 6 and 7, but I have only one item A, so always for all those fields the maximum obtainable value will be 5, as I don't have any more items. Now for this field, in this field means that the capacity of my knapsack is 1 and I have these two items A and C. To obtain the maximum obtainable value, I can use these two items. So to find out the maximum obtainable value for this field, I need to see that can I use this item C or not. The weight of the C item is 2, but the capacity of my knapsack is 1, so I can't use the item C in this field. So without using this item, the maximum obtainable value we know that 5. So for this field the value will be 5. Now for this field, the capacity of the knapsack is 2 and I have these two items A and C, and now we will see that can I use the item C for this field or not. Using the item C for this field, the value will be 3 plus, using the item 3 plus I have used two size. After using the two size, the value will be 0. The capacity of the knapsack is 2 and I have also used two size, so the remaining size will be 0. This will point here. I have used the item, so the value will be 3 if I use the item C, using the item C. And without using the item C, we know that when the capacity of the knapsack is 2, the maximum obtainable value is 5 without using the item C, not C. So here the maximum value is 5. So for this field the maximum obtainable value will be 5. Now for this field, the capacity of the knapsack is 3 and I have just two items, one A and C. Now we will use the item C for this field, so the value will be, using the item C, 3 plus I have used two size, so my remaining size is 1, and I have used the item, so this will point here, plus 5 equal 8, using the item C. And without using the item C, the maximum obtainable value when the capacity of the knapsack is 3 is 5. Here the maximum value is 8. So the maximum obtainable value for this field will be 8. Same when for this field, when the capacity of the knapsack is 4 and I have these two items A and C, so the value will be, using the item C, 5. Using the item C, the value 3 plus I have used two size, 4 minus 2, this will point 2, and as I used the item, so this will point here, 5 equal 8. Without using the item, the maximum obtainable value we know that 5. Here the maximum value is 8. So the maximum obtainable value in this field will be 8. same for this, for those field will be 8, as I only have these two items, and increasing the capacity of the knapsack, so the maximum obtainable value will be 8. Now for this field, the weight of the item B is 4, but the capacity of the knapsack is 1, so I can't use the item B. So without using the item B, the maximum obtainable value when the capacity of the knapsack is 1 is 5. We know 5. Here also I can use the item B, as the weight is 4, so the maximum obtainable value will be 5. Here 8. Here the capacity of the knapsack is 4, and the weight of the item B is 4, so I can use the item B. So after using the item B, the value will be 2 plus, I've used the 4 size of weight, the capacity of my knapsack is 4, so it will point here 0 equal 2. And without using the item B, the maximum obtainable value when the capacity of the knapsack is 4 is, we know, 8. Here the maximum value is 8. So the maximum obtainable value for this field will be 8. Now for this field, the capacity of my knapsack is 5, and now I will, if I use the item B, then the value will be 2 plus, I've used for size, the capacity of 5, remaining size is 1, this will point here 5 equal 7 using the item B. And without using the item B, we know that the maximum obtainable value is 8. Here the maximum value is 8, so the maximum obtainable value of this field will be 8. Now we will see for this field. The capacity of the knapsack is 6. Using the item B, the value will be 2 plus, used for size 6 minus 2, this will point here 5 equal 7. And we know that without using the item B, the maximum obtainable value is 8. So here the maximum value is 8. Now for this field, the capacity of the knapsack is 7, and if I use the item B, then the obtainable value will be, use the item B, 2 plus, use size 4, capacity of 7 minus 4, 3, this will point here 8 equal 10. And without using the item B, we know that maximum obtainable value will be 8. Here the maximum value is 10. So for this field, the maximum obtainable value will be 10. Now we will find out for these fields. Here we have all these items. Here for the item, we will see for the field. Here the capacity of the knapsack is 1, and the weight of the item D is 5. So I can't use the item D. So without using the item D, we know that maximum obtainable value is 5. Again for 2, it will come from 8, 4, 8, for 5. Now the capacity of the knapsack is 5, and the weight of the item D is 5, so I can use the item D. So after using the item D, the value will be 6 plus 5 minus 5, 0, this will point here equal 6. And without using the item D, the maximum obtainable value when the capacity of the knapsack is 5, we know 8. Here the maximum value is 8. So for this field, the maximum obtainable value will be 8. Now for this field, here the capacity of the knapsack is 6, and after using the item D, the value will be 6 plus, I have used the 5 size 6, I have a remaining size 1, this will point here 5 equal 11. And without using the item D, we know that the maximum obtainable value is 8. So here the maximum value is 11. So for the field, the maximum obtainable value will be 11. Now we will find out our final value. Here the capacity of the knapsack is 7, and we have all those items. So after using the item D, the value will be 6 plus, I have used 5 size, so I have a remaining size 7 minus 5 equal 2, and this will point here 5 equal 11. And without using the item D, we know that maximum obtainable value is 10. Here the maximum value is 11. So for this field, the maximum obtainable value will be 11. And this is our final answer, that using the capacity of the knapsack and using all these items, the maximum obtainable value will be 11. So which items we will use to obtain the maximum value? Here 11 doesn't come from the upper row, so I have used the item 5 D, weight 5 and the value 6. And after using the size 5, 7, 2, this will be here 5 point here. This 5 has come from the upper row, and this 5 also come from the upper row. This 5 didn't come from the upper row, so this 5 I have used from the value here. So I have used the item A. 1 and the value is 5. So the set will be used A and D. For A and D, the weight is 6 and the maximum obtainable value is 11. So in this, if I use into my knapsack A and D, then I will get the maximum value from those items. Here the total weight of A and D is 6, even though the capacity of my knapsack is 7, but I can't the remaining one size, as this is a 0-1 knapsack problem. Now we will see the implementation of the problem. First, L for loop. This is then equal the number of items another loop for all those weights. So before implementation, we'll see that we have a two array, one array for the weights and another array for corresponding values, WT for weight and val for values. And then equal the capacity of the knapsack. these two loops will cover those fields. That means for I equal 0, I less than equal number of items 1, I equal 1, I equal 0, 1, 2, 3, those items. And this for loop will cover the weights. That means 1, 2, 3, 4, 5, 6 in this loop. Now we will set the base case value. If I equal 0 or W equal 0, the value will be else if the weight of the item is less than the capacity of the knapsack. Weight I minus 1 is greater than total weight of the knapsack capacity. This W represents the capacity of the knapsack, and this represents the weight of the items. If the weight of the items is greater than the capacity of the knapsack, then we will put the value of previous items. This condition represents like these fields. Here the capacity of the knapsack is 1, but the weight of the item B is 4, so I can't use the item B. So, and as a result, I need to get the maximum obtainable value from without using the item from the previous row. Now, if the item value is less than the capacity of the knapsack, is K of I W equal maximum value using the item value of minus 1 plus remaining maximum obtainable value of remaining size K of I minus 1 W minus WT I minus 1 W minus WT I minus 1 with the maximum value of without using the item. This represents that without using the item, the maximum obtainable value, and this represents that using the item, maximum obtainable value. And from those field, the maximum value we will put in this field. Suppose for here, for the size that weight of the item B is 4, like here, suppose here, using the item 4, the value we know that 2 plus 5 equals 7, this will represent 7, and without using the item we know that the value is 8, this will represent 8, and from these two fields the maximum value is 8, and we got the maximum obtainable value is 8. Now the complexity of the problem is big O of number of items into capacity of the knapsack. Hope we have enjoyed the video. Thank you.